we are starting a new chapter, Permutations and Combinations. We start with an example where we discuss something. Find the number of three-letter words with or without meaning that can be formed using the letters of the word can. That means C, A and N are the letters that we can use, and we have to form all possible words. These words, most of them won't really have any meaning, but still we have to say how many of them can be formed. And additionally, there is one more restriction. If repetition of letters is not allowed, okay, so you cannot do things like C, 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 so such things are not allowed. It's like having three empty boxes. Each box is to be occupied by one letter. In how many ways can we do this, and what are the ways actually in this case? Because there are only three letters, so there are only a few possibilities. And one quickly realizes that there are these 6 possibilities. These are the only ways we can consider a 3-letter word using C, A and N if letters cannot be repeated. Say you decide to fill the first box with C. Then the second and third boxes can be filled either like this A and N, with A and N in that order, or with N and A in that order, for that first box having C. Just like that, if you decide to put A in the first box, then the second and third box can be filled respectively with N and C, or with C and N. Or if the first box has N, then the second and third box can have respectively A and C or C and A. And these are all the possibilities. So the total number is 6. Now we have to decipher this 6. Exactly how are we getting 6? We of course see this pattern that for this single C, we have these 2 possibilities. For this A, we have either N and C or C and N, and similarly for N. And because there are 3 letters, so the first box can be filled in 3 ways, either like this or this or this. And corresponding to each such way, there are 2 ways of filling the second and third box. So that way we are getting 3 times 2, that is equal to 6. That 2 of course is the number of ways of filling the second and third box. But exactly how? Let's see. Say you have chosen C for the first box. So C is gone and the first box is also filled. Now you are left with 2 letters A and N. Using them you can fill the second box in how many ways? 2 ways. Either you put A in the second box or N. But again, because repetition of letters is not allowed, so once you have chosen, for example, A for the second box, you are left with only one more letter for the third box. So that gets fixed, it's N. Or it's the other way, you choose N for this one and you have only one letter for the third box. So it's the number of ways of filling the second box, that is 2. And once one such choice has been made, then further, whatever you are left with, the number of ways of filling the third box with that leftover thing is, in this case, 1. So that is how you are getting 3 times 2 times 1. And that's 6. That is the total number of ways in which you can fill these 3 boxes without repeating letters. So that's how the number 6 comes. Do you see the reason for multiplying these numbers and not adding? Because of this. Let's take another example with more letters and see what happens there. This example also asks the same thing, but in this case the word is rose. It has 4 letters, R, O, S and E. So there are 4 boxes to be filled. Now what are the ways we can do this? Let's first write down the ways, actually writing down all the ways, and then we will try to see how the number is coming and what the number is. These are 6 ways of filling in these boxes, with the first box constantly filled with R. Then the remaining 3 boxes can be filled in with O, S and E, and the number is 6. Do you see how? And these are all the possible ways. I mean, do you see how this is related to the previous example? Once you have chosen R for the first box, this is just the previous example. Only there we had C, A and N, here we have O, S and E. So that's how we are getting 6 ways of filling these boxes with R in the first box. However, these are not all the possibilities, because you can have O also in the first box, S also in the first box and E also in the first box. But you do understand that for each of those 3 possibilities, again the number will be 6. So the total number will be 4 times 6, or let me just write it down. It's 24, which is 4 times 6, or this. I have put this within parentheses to indicate that it comes from a previous calculation. So a nice pattern you are seeing emerging here: 4 times, 3 times, 2 times, 1. Now can we extend this, say, to a word having 5 letters or 6 letters? Let's just go for a word having more letters. You consider the word dream. It has 5 letters. And one more thing, all the letters are distinct. That has been the case with rose as well as can, right? So now how many ways can we rearrange the letters to form words which are with or without meaning, but letters cannot be repeated? So you can imagine that now in this case there are 5 boxes which are to be filled in with these letters without repetition. So you start thinking of the possibilities. Say you decide to fill in the first box with D. Then that leaves you with this ring part. Okay. And using these 4 letters, you are to fill these remaining 4 boxes. But that remaining 4 boxes are to be filled in with 4 letters, keeping the condition intact that letters cannot be repeated. It is essentially just like rows. So the number of ways of doing that, provided that the first box has been filled with D, is 24. We have already calculated that right now. However, the first box itself can be filled in 5 ways using any one of these 5 letters, and corresponding to each such way, there are 24 ways of filling in the remaining boxes using the other letters. So what number are you getting now? 120, which is 5 times 24, or if you write 24 like how we wrote it there, then it becomes 5 times, 4 times, 3 times, 2 times 1. So that pattern continues. So now can I say what the general case will be? Think of an imaginary language where the alphabet is infinite. There are infinitely many letters. Luckily, we do not need such language. I mean, I'm talking about natural language like English, Hindi, like that. So we have such an alphabet, suppose. And in that language, this is a word using n different letters. All these AIs are different letters in that alphabet. Now we have to know the number of ways we can rearrange these letters, or in other words, using these letters, we want to know how many words with or without meaning we can form if letters are not to be repeated. So you can imagine that again, there are this time n boxes to be filled in using these letters, keeping in mind that letters cannot be repeated. And following the pattern that we saw in those examples, this should be the number. N times n minus 1 times n minus 2, and like that the pattern goes. And finally you reach 1. And even in this general case, if you take a few moments and try to think of it, it makes sense. The first box needs to be filled in using these letters. There are n possible means available letters. Using them, you can fill in the first box in n ways. Corresponding to each such way, you can fill in the second box using any one of the remaining n minus 1 letters in n minus 1 ways, because each such way of these possible n ways gives you n minus 1 further possibilities. So we take the product of n and n minus 1. Now once you have chosen a letter for the first box and also a letter for the second box, how many letters are you left with? N minus 2. Using them, the third box can be filled in n minus 2 ways. That is why further you multiply n minus 2. Okay, so that's how it goes. So this will be a big number or small number depending on n, as we saw there, that when n is 3, this number is 6, when n is 4, it's 24, when n is 5, it's 120. It grows very quickly, but it is a bit cumbersome to keep writing this. Instead of it, if we have a compact notation, it would be nice. And that notation is this or this. They mean the same thing, this number. N followed by the exclamation mark, or this one is no longer used. Okay, it has fallen out of use. We use this one. And how to read it? To read it, you say n factorial, factorial. And we extend the scope of this symbol n factorial slightly by including 0 also. However, the definition here of this symbol 0 factorial is that it just is 1. Do not try to think of 0 factorial as this product. Okay, it will not make sense, because in the context of the discussion that we had just now, which gave us this number, n is a positive integer. It is just something that we have separately defined, and you will later see why we do it. I mean, why we need this symbol and why it is okay to define it to be 1. Okay, right now it won't be really very clear, but you remember this. So if I now change the example and we consider the word Lucifer, okay, it also has distinct letters. And how many letters are there? 1, 2, 3, 4, 5, 6, 7. So that same number for this word will be 7 factorial. If you want, you can calculate its value, but that's not the point. The point is that it is 7 factorial, whatever it is. And with this small discussion on permutations and combinations, let me end the video here itself. I did not, however, even say what permutations and combinations are. We will see later what combinations are, but a permutation is just an arrangement of some objects, just like the arrangements of letters that we saw today. In coming videos, we are going to consider more involved and complicated cases, because obviously we are not always going to have words like this, where all the letters are the same. If letters already are repeated, then what happens? Things are going to be complicated. Now, in this part, we are not really interested in actually finding the arrangements or permutations, but rather the total number of possible permutations. That's the aim.